This next problem is an algebra problem, and more specifically, we can call it a systems of equations problem. In systems of equation problems, we have multiple variables and multiple equations. Generally, they ask for the value of one of the two variables, or they ask for the value of an expression. Like in this problem, they actually ask for the value of x plus y. Now, whenever they ask for the value of an expression, it is very often the case that you should be using something called the combination method. That really just means combining the two equations together by either adding them to each other or subtracting one from another. In this case, you should subtract the bottom equation from the top equation, but let me explain why. If we are looking for the expression x plus y, we are looking to try to make, once we've combined them, on the left side, just an x and a y, and on the right side, whatever that difference is. In this case, it would be 3. If we were to add the bottom from the top, we would get 11x plus 5y. Now, let me show you how this looks. You should write it out like this. We put it all in parentheses so you can see that everything should be negative because we're subtracting it. 6x minus 5y, or sorry, 6x minus 5x is just x. And 3y minus 2y is just y. And 16 minus 13 is 3. We are automatically left with the expression they're looking for. And the answer would just be 3. Now, if you've never done this before, let me explain just for a moment why this is even possible. In algebra, you're allowed to do the same thing to one side of the equation as you can do to the other. Now, it looks like in this problem that we're not doing that. We're actually subtracting 5x plus 2y from one side of the equation and subtracting 13 from the other. However, 5x plus 2y is 13. They equal each other. So even though we're subtracting something that looks different on one side as it looks on the other, because they equal each other, we are essentially subtracting from the top equation the same thing on both sides. But because they're written differently, it allows us to manipulate the variables. And that's the point of this problem. Whenever the question is looking for an expression, it is very often the case that you should be thinking, how can I manipulate these two equations? Which one do I need to subtract from the other? Or should I just be adding the two in order to make an expression that looks like the expression they're looking for? And that's how you should do it.
Hi, I'm Justin, co-founder and CTO of Achievable. If you've enjoyed this video, you'll love our GRE course. Achievable GRE includes everything you need to get a top score. Our comprehensive online textbook, videos just like this one on dozens of key topics, a built-in study planner to keep you on track, an essay grader with instant feedback to improve your writing, thousands of drillable review quizzes, and plenty of full-length practice exams. Our course is competitively priced, and you can try it out for free to see if our instructional style is the right fit for you. Follow the links below to get started.